Hello everyone, welcome back to Algebra 1 with Miss Betsy. Today we are going to be discussing inequalities. If you're using the same text I am, we are in chapter 5.1, beginning on page 182. This is Algebra 1 for Christian Schools, published by Bob Jones University Press. You can still gain value from this video even if you're not using the same text because inequalities are inequalities. First, before we get started, I'd like to ask you if you can tell me what do you get if you cross a parrot with a shark? And what you get is an animal that will talk your head off. So let's go ahead and dive right into this. And if you happen to be watching this video before I get a chance to go back and look at some of my other ones, it's possible to my class that the videos where I was talking about word problems that I told you it was pre-algebra, obviously wasn't using the pre-algebra book. It is your Algebra 1 video. So, chapter 5.1, inequalities. We know that when two things are equal, they represent the same quantity, they have the same value, they have the same worth, but when things are unequal, they're not the same. They don't have the same value, and that's what inequalities are. And we have, just as we have a symbol that represents equality, 2 plus 3 is equal to 5, we also have symbols that represent less than and greater than. You are probably already familiar with these symbols. If you're not, now's the time to learn them. The point always goes towards the number that is smaller, goes towards the quantity that is smaller. And you're all very familiar with the symbol, the sign that you see. It looks something like this. Let me see. Another example of why I do not teach art. That's a cigarette. If it's slashed, that means no smoking. When you slash something, we say that you are negating it, or making it negative, or making it not true. So just like you have an equal sign, 2 plus 3 is equal to 5, 4 is less than 5, 5 is greater than 4, we can use the slash to negate something. So if I were to change this here, is it true that 2 plus 3 is equal to 4? Well, no, of course not. So you can say 2 plus 3 is not equal to 4. Now, what if we said, instead of saying that 4 was less than 5, what if we changed both of these and we put 4 is less than 3? Is that true? No. 4 is not less than 3. 5 is not greater than 6. So when you slash your symbol, you're just saying the opposite. Not equal to, not less than, not greater than. We also have symbols that can be less than or equal to, greater than or equal to. So if I have less than or equal to, is it true that 4 is less than or equal to 2 plus 2? Well, is 4 less than 2 plus 2? No, it's not. But is 4 equal to 2 plus 2? Yes. When you have less than or, when you have greater than or, equal to a number, when you have that or connector in there, only one of the statements has to be true for the entire statement to be true. It's like if your mom says, okay, you may go to the movies tonight with your friend, but in order to do that, you must either clean your room or wash the car. So what do you have to do? Do you have to clean your room and wash the car? No. Does mom care if you clean your room, if that's what you do, or if you wash the car? No. She said, I don't care which one of these two you do, but you have to do one of those in order to go to the movie. Now, on the other hand, if mom said, if you want to go to the movie tomorrow, you have to wash the car and clean your room, and you only did one of those, and then you went ahead and went to the movies, would you be in trouble? Well, yeah, because mom had not said do one. She'd said to do both of those. So that's all we have with not equal to, greater than or less than or equal to. All of these different symbols of showing the relationship between numbers. And let's consider how we would graph this, how we would show this. For example, we have this equation here. 3x plus 5 is equal to 10. I'm going to change this. 3x plus 4 is equal to 10. What if I gave you the instructions that said solve and graph on a number line? Solve, graph the solution on the number line. What would you need to do in this? Well, first you'd need to use your properties that would enable you to solve this equation. First, you would subtract 4 from both sides of the equation. You have to subtract from both sides of the equation to keep it in balance. You have 3x is equal to 6. Divide both sides of your equation by 6. And you have x is equal to 2. Now, is that all that you have to do? No. Because your instructions say graph the solution. So how are we going to graph this solution here? X is equal to 2. You draw your number line, show a couple of points. There is one and only one solution to this equation. Only one solution for x, that's the value 2. Just like there is only one Jesus, there is one way to salvation, and that's through the blood of Jesus. One and only one solution. So that's what we have when we have an equal sign. Let's change this, though, and say, what if instead of saying equal to 10, we said less than 10? And so we don't have to go ahead and solve this equation, this inequality just yet. Let me make this very easy. X plus 4 is less than 10. Well, what happens if x is 1? Well, 1 plus 4 is less than 10. That's true, isn't it? What about if x is equal to 2? 2 plus 4, that's less than 10. Well, what if x is negative 100? You have negative 100 plus 4. Is that less than 10? Well, negative 96 is certainly less than 10. So you see what I'm going here is when we had the equation previously, when we had 3x plus 4 is equal to 10, there was one distinct, one unique solution. But now, when we have an inequality, there are many solutions. An infinite number of solutions, actually, because you're never going to come up with an end to the numbers that you can use for x that will give you a net result that's less than 10, because any negative number from now until the end of time is going to work. So how would you graph this? Well, you are going to graph this on a number line. And I'm just going to show you right now what the solution is. And we'll come back to this in just a minute. Okay? If we solve this equation, 6 plus 4 is less than 10. Is 10 less than 10? No, 10 is equal to 10. So if we have a value of 6, we can't put a 6 into this inequality and have it be true, can we? 10 is not less than 10, but anything smaller than 6 is going to make our inequality a true statement. So you'll remember from way back at the beginning of our book, we used an open circle on our number line if that number right there was not a part of the solution. So this is how we're going to graph inequalities. It's going to be a range of numbers will be the solution to your inequality as opposed to a single point when you have an equality. So let's go ahead and look at these couple of examples right quick, and then we'll be done with this video. Example number 1 says graph x greater than or equal to a negative 3. So we're going to graph it on the number line. We're referencing x around a negative 3. So we can show 0, negative 3, and a positive 3. Do you have to use exactly the same numbers that I do when you're graphing? No, but as you watch me, you'll learn to see sort of a shorthand way of writing these numbers. This says that x can be greater than negative 3, or it can be equal to negative 3. If x is equal to a negative 3, that's going to be a solid circle. So we have x is equal to 3, negative 3, or greater than negative 3. That's all there is to graphing this inequality. Let me do one more for you. And this is going to be an important one to understand, because here we're showing one where we have negated. We have x is not equal to 2. 0, negative 2, 2. We know that we're talking somehow about 2. So we have to show our 2 on the number line. Now what does our statement here tell us? It tells us that x cannot be equal to 2. So there's going to be an open circle around the 2. But that's the only qualifier that we have in this statement. So if x cannot be equal to 2, it can be equal to everything else. So the entire number line is shaded with the exception of the location for a positive 2. That's all you're going to be doing in section 5.1. Your homework should go lickety-split for you. Just make sure you follow the instructions, and I will see you next time.